Example 7. Find the fifth degree polynomial function that has a y-intercept at 0, 72, crosses the x-axis at 2, and touches the x-axis at -2 and 3. Okay, this example is very similar to example 6. Okay, you are trying to come up with the formula or the function for a polynomial that has these characteristics. Okay, so example 6 gave you the picture of the polynomial. Okay, and you had to construct your function based off of the picture. Okay, now we don't have a picture. We're just told in words what the characteristics of the polynomial are. Okay, so we are dealing with a fifth degree polynomial function. Okay, we know the y-intercept, and we know the zeros or the x-intercepts, and we know the behavior at each. Okay, so you have the first x-intercept is going to be at 2. Okay, and so there you're crossing. Okay, so the multiplicity has to be odd there. So we'll go ahead and write it down. And remember, when you build these, you want to build in terms of the smallest degree polynomial possible. So we'll go ahead and put a multiplicity of 1 on it. You don't want to use multiplicity 3 or multiplicity 5, because then you start getting into a really high degree polynomial. Okay, so again, your x-intercept is 2. Since it's crossing there, the graph is crossing at that intercept, we know that it has to have an odd multiplicity, so we're going to use the smallest odd number possible, which is 1. Okay, then we have 2 more x-intercepts. We have one at -2, and we have one at +3. Okay, and we're touching there. Okay, and so we know, because we're touching there, that these 2 x-intercepts have to have an even multiplicity. Okay, so we'll go ahead and assign them the smallest even number possible, so multiplicity 2. Okay, so that's kind of what we get out of the verbal description. Okay, just like in example 6, you are going to start building the factorization. Okay, for the formula. Okay, so again, if this is your 0, let's start with x equals 2. Okay, think about the factor. Okay, so if x equals 2 is your 0, the factor has to be x minus 2. Okay, because I'll come down here. If we have x minus 2 and we set that equal to 0 and we solve this for x, okay, move the 2 over, you're going to get x equals +2. Okay, all right, so that's going to be your factor. Okay, I'll go ahead and put parentheses around it. Okay, we know that this factor is going to have a multiplicity of, or sorry, this 0 has a multiplicity of 1, so the factor will be raised to the first power. Okay, all right, next. Okay, x equals -2. Okay, so what's the factor got to be? Well, it's got to be x plus 2. Okay, because if you took this factor and you set it equal to 0 and you solve to get the intercept, okay, subtract 2 from both sides, you would get -2. Okay, all right, so that's your factor. Okay, because -2, the intercept, has an even multiplicity, or sorry, since it touches, it has an even multiplicity. Okay, so the multiplicity has to be, or we assigned a multiplicity of 2, so this factor has to be raised to the second power. Okay, so that you get the you get -2 as an x-intercept twice. Okay, all right, so then lastly, let's come up with the factor for x equals 3. Okay, so if x equals 3 is a 0, that has to come from x minus 3. Okay, again, if you took x minus 3, set it to 0, and solve this, you would get x equals +3. Okay, so that's your factor. Okay, again, we know the graph is touching the x-axis at this point. Okay, so that implies an even multiplicity. We use the smallest possible, so this factor needs to be raised to the second power. Okay, all right, so now we can go ahead and multiply our factors together. Okay, so we're going to get f of x is equal to x minus 2 times x plus 2 squared times x minus 3 squared. Okay, going back through the problem, we have covered pretty much everything, okay? If you look at this, like, do the little shortcut, this is x times x squared, that's x cubed, times another x squared, that's going to be x to the fifth, so this is a fifth degree polynomial, okay? But we have not talked about the fact that there is a y-intercept at 0.72, okay? So we need to account for that, okay? Every single time I talk about this problem, every semester, every time I go over this problem, we do it right after we do example 6. And I ask people, how do you think you would handle this, y-intercept at 0.72, okay? A lot of people tell me, okay, I'm going to tack on a plus 72, okay? That is not correct, okay? Look at the calculator. Remember, you can check yourself here, okay? So look at the calculator. Here's example 6, so let's get rid of that, okay? Let's type in what we know, okay? We built this guy, okay? We built this first part, so x minus 2 times x plus 2 squared times x minus 3 squared. Okay, so let's take a look at this. I'm not worried about the 72 just yet, okay? Obviously, look at the window I had initially. We're going to need much bigger y values, okay? Our x-intercepts are around these numbers, so I will keep my x scale kind of small from -6 to 6. I'll keep that and put a tick mark every 1 unit. But remember, we're expecting a y-intercept of 72. That's a very high y value. So I am going to go ahead and do, let's do y values. Let's go from -100 to +100, okay, in the y direction. And I'll put a tick mark every 10 units, okay. So this might give us a better picture, okay, of what we've got. All right, so again, what I put in the calculator is what we built, okay, not with the 72 on the end, okay. So take a look at it. That's exactly what I have in the calculator right here, okay. If you notice, there is no y-intercept at 72, okay. If you do a second calculate the value, so hit option 1, at x equals 0, your intercept is -72. We want a y-intercept of +72, okay? So we've got to deal with this, okay? First of all, like I said, just adding 72 to the end is not correct, okay? I didn't show you that on the calculator, but if you had taken what we had, okay, and just did a plus 72, okay, that does not give you a y-intercept at 72, okay? So that is not correct, okay? All right, so you have to do exactly what you did in example 6. We need a specific leading coefficient that is going to force us through this point, okay? So yes, this is the y-intercept, but also this is the point that you have to force your polynomial through, okay? So I'm going to go ahead and put an a here. I need to solve for the a value, the specific leading coefficient that I need to force my polynomial through the point 0.72, okay? And then we're going to plug in, okay? So remember, this is your y value, okay? So what we're going to do here, let me go ahead and just set it up, okay? We're not plugging in for a because we're solving for it, okay? So let me just kind of write this in, and then we'll plug in everything we need. All right, so here we go. So we know that if x is 0, the y value has to be 72. So if x is 0, okay, the y value has to be 72, okay? So this is the equation I can build here, and now I'm going to be able to solve for a, okay? So we're going to get 72 is equal to a times -2 times 2 squared times -3 squared, okay? So we're going to get 72 is equal to a times -2 times 4 times +9, because -3 times -3 is +9, okay? We're going to get 72 is equal to a times -2 times 4 is -8 times 9 is -72, okay? And then if we want a, we've got to get it by itself. So since you're multiplying by negative 72, do the opposite. Divide by negative 72. Okay. So the leading coefficient you need is negative 1. Okay. Final answer is not the a value. It has to be the formula itself. Okay. So you need to come back up here. This is the formula you had built. Okay. But now you've got to plug in the specific a value. Okay. So our final answer is going to be f of x is equal to a, which is negative 1, so we can just put a negative sign, okay, times times x minus 2 times x plus 2 squared times x minus 3 squared. Okay, here's your final answer. Okay, so now let's go check out the calculator and see if this fixed our problems. Okay, all right, so here's what we had earlier. Let me take out this plus 72. Oops, can't see what I'm doing. All right, so I took out the plus 72, and then I'm going to go ahead and insert the negative 1 as my leading coefficient, okay? And let's see if this gives us the graph that we want, okay? All right, first thing to notice, second, calculate the value at x equals 0. Okay, so at x equals 0, my y-coordinate is positive 72. So I've got the correct y-intercept. Hooray. All right, let's check out the x-intercepts, okay, and the behavior at each one, okay. So we know that the first x-intercept is at 2. So I'm going to second calculate the value at positive 2, okay. It's going to highlight that point, okay. This scale, it's kind of squished because remember your y-axis is going from negative 100 to positive 100. So doing this, I can really read it easily. It's going to highlight that point and tell me the coordinates are 2, 0. Okay. If you really look at it there, it looks like you're crossing. You could zoom in on it, but it seems to be that you're crossing there. Okay. Let's check the other x-intercept. So the next one was at negative 2. So I'm going to calculate the value at negative 2. Okay. So it's going to highlight the point, give you the coordinates, negative 2, 0. So this is indeed another x-intercept, and you are touching there. So that's great. Okay. And then the last x-intercept is at 3. So second, hit 1, calculate the value at 3. Okay. It's going to highlight the point, 3, 0. Okay. So that is an x-intercept. Okay. Again, it's really hard to tell what's going on at these two x-intercepts, 2 and 3. We could zoom in on it. Okay. If I move my cursor, I'll move it right there. Okay. And then hit enter. It'll zoom right there. Okay. So this is 2. You can see you're crossing there, or actually, yeah, this must be 2. Let me see. Okay, so I can calculate the value at 2. Okay. It's right there. Okay. So here's 2, you're crossing. And then second, calculate the value at 3. Okay. You are definitely touching there. Okay. So that's what you wanted. Okay. So just getting back to the original graph, let me go back really quick. Okay. This is exactly what we wanted. Okay. It's got the correct x-intercepts or zeros. It's got the correct behavior at each one. And this guy has, a y-intercept at 0, 72.